going to run over our special quadrilaterals, and we're going to focus on rectangles, rhombuses, and squares. So let's go ahead and get started. So for rhombuses, what we have here, for rectangles, what we have here is a quadrilateral with all the properties of a parallelogram, which we discussed in the last video, and all the properties of an isosceles trapezoid, which we did not discuss, but it is in my other YouTube videos. Because of Webex online learning, we've cut a few things out, which is not a good thing, but it's just the way it is because we started school a few weeks late and so on. We just only have so much time. But I'll run through that real quick. So a parallelogram, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. In a isosceles trapezoid, we have at least one set of parallel sides. So a classic trapezoid, one set of parallel sides. The base angles are congruent, and the base angles, the ones that are touching the parallel sides. And diagonals are congruent. They're the same length. They don't bisect each other, but they are the same length. So the rectangle has all those properties, and let's run through them. So opposite sides are parallel from the parallelogram. Opposite sides are congruent from the parallelogram. Opposite angles are congruent from the parallelogram. And consecutive angles are supplementary, again inherited from the parallelogram. It's like genetics. Diagonals bisect each other from the parallelogram. Now this four angles being right is a combination of things. So in the trapezoid, base angles are congruent, and that's opposite your, so this would be congruent to this right here, and this would be congruent here. These would be congruent. But what happens is if they're supplementary and congruent, they have to be 90 degrees angles. So all these are going to be 90-degree angles. It's the only way it can happen. When you marry a trapezoid and a parallelogram, you get right angles on the corners. And the other one is the diagonals are also going to be congruent. That is from the isosceles trapezoid. So moving on. So just like in previous videos, we have two ways of determining skill in geometry. One is through proofs and one is through algebra. We selected the algebra method, and that's exactly what we're going to do here. We're going to give you a rectangle. That's key information right there. You got to know which quadrilateral you're dealing with. And then you just plug in what you know. Well, I do know ahead of time that these are all 90 degrees. My diagonals are going to bisect each other. They're also congruent. And another cool property is that these segments, DP, AP, BP, CP, are all congruent. It forms four isosceles triangles. These two are going to be congruent. These two are going to be congruent. We can prove that through side angle side, 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 whatever we need. So what we're going to do is fill in AC is 4x minus 13. There's 4x minus 13. That's the whole length. DP is just this x plus 7. Just part of the length. Well, this is x plus 7. Over here is also x plus 7 because it's bisected. And since diagonals are congruent, this 4x minus 13 will equal to the whole thing of dB, which is 2x plus 14. And that's what we're going to do. So by setting this up, you've demonstrated knowledge of your definition. 2x plus 14. Subtract 2x. Get rid of that negative 13 by adding the opposite. So I have 2x is equal to 27. Looks like we're going to get a decimal here, which is perfectly fine. Half of 27 is going to be 13.5. All right, so I'm going to take that 13.5 and plug it in here, or I could plug it in here. It doesn't matter. If I plug it in here, I'm going to get 20.5, 20.5, and the whole thing is 41. So AC is also going to equal to 41 because when I plug it in there, I absolutely get 41. Okay, next example. And again, always put these on pause. Go back, redo this problem on your own scratch sheet of paper. You learn by doing. That's what Socrates, at least that's what Bill and Ted called them. That's how you learn, all right? So rectangle KLMN. Now these are just a little puzzle angle games, and we'll do some of those if we ever get to that circle stuff. So rectangle KM is given, and first of all, we know that all the angles are 90 degrees. These corners are all 90. Okay? And we can do further exploration. We have isosceles triangles, so we know base angles are the same. So all we need is one angle, and we're going to get it right here. It's going to be 70. So 70 is what's given. And with that, we can fill out every single angle. If this is 90 and that's 70, this is 20. Base angles are the same. So that's 20. That makes that 70. If that's 70, this is also 70, and that makes that 20. And this also makes this 20 and 70. So I just went right around. To find these middle angles, well, sum of a triangle is 180 degrees. If that's 140, this has to be 40. Linear pairs, that makes it 140, 40, and 140. So what I did was I filled out this first. Fill out your picture first, then fill in all this stuff right here. And you can just go in and go, okay, 20, angle 4 is 70, angle 6 is 20, and you kind of just jump around. Angle 8 takes me a while to find, 70, so on. These are all going to be 70s and 20s. Just every single one of them. All right? Okay, next one. So what do we got here? Another rectangle, RSU. So I'm going to do R, I'm always pairing it, SU. This right here is 3x minus 5. UST. UST is 4x plus 4. UST. Okay. Definition time. Rectangle. All corners are 90 degrees. So if all corners are 90 degrees, we have the angle addition property all the way back from unit 1. This plus this is equal to that. Well, I have 7 x's. I have a negative 1, and it's equal to 90. Add the 1, 7x is equal to 91. 7 goes into 91 a bunch of times, and that is 13, because 70 and 21. Alrighty, so that's going to be 13. And it's asking for this. So I got my algebra answer. Your algebra teacher is quite proud of you. So we're going to plug this into RSU. Where is RSU? Right here. So 3 times 13 minus 5. That's 39 minus 5 is equal to 34 degrees. And if I asked you to fill in every single angle, you can absolutely do that. Because if this is 34, that's going to be its complement. That's going to be 56. All right? And then we can just go right around and do the exact same thing we just did. Okay? Moving on. So now we're going to talk about rhombuses. Rhombuses are one of my favorite things. Now I don't have the family tree up here, but a rhombus has all the properties of a kite and all the properties of a parallelogram. Now we didn't talk about kites either. Kites are utterly fascinating. They have a lot to do with circles. We haven't talked about circles either. But I might have a couple of videos on my YouTube channel that does talk about kites and circles. Well, a kite is a special type of parallelogram where the product of opposite sides are equal. But basically your traditional high school textbook will say consecutive sides are congruent. So a kite, this side will be congruent to this side. And they're two distinct pairs. And then they would say this side is congruent to this side. Has to be two distinct pairs. Well, that still fulfills the definition of a kite. But it turns out that all four sides are now equal because it's a parallelogram as well. That means opposite sides have to be congruent. Consecutive sides are congruent. Opposite sides are congruent. That makes all four sides congruent. But it's not a square. Another property of the kite is the diagonals intersect at perpendicular. Now, kites don't bisect both diagonals. Only one diagonal is bisected. But a parallelogram, it does bisect. So the diagonals bisect each other. So we have something like that looks like this. Oops, I better make it 3, and I better make these 2 because these sides don't all equal. And what you have is a right triangle, right triangle, right triangle, and right triangle. Kites are fascinating. Because of this, and we can prove triangle congruency through side, angle, side, all kinds of different properties, we're going to find that the diagonals bisect these angles. And that's inherited from the kite family. These angles are bisected here and here, here and here. And we can prove we have some congruent triangles as well. So let's run through these properties. Oops, it looks like I have some of that covered up. We'll live. So opposite sides are parallel, parallelogram. Opposite sides are congruent. Opposite angles are congruent, all parallelogram. Consecutive angles are supplementary. Diagonals bisect each other. So this is all the properties of a parallelogram. All four sides are congruent. That's a natural product when you marry a kite to a parallelogram. Diagonals are perpendicular and diagonals bisect. You can't quite read that. opposite angles. So they're angles. So lots and lots of properties. And they diagonals intersect at right angles. So here we have a rhombus, okay? A special type of kite and parallelogram. So we have RST is 67. So I'm going to put a 67 right over here. Well, given definition of a parallelogram, opposite angles are congruent. That's also 67. Another property of a parallelogram is that consecutive sides are supplementary. So if this is 67, this is going to be 113. And this is also going to be 113. I can find every single angle on here because diagonals bisect these angles. We're looking for RSW. Well, it's just going to be half of 67. That's going to be 33.5. At least I'm pretty sure it's 3. Yep, it's 33.5. 33.5 because that's 33.5. All right. And these will be half of 113, which is 56.5. Okay. 56.5, so on. Okay. And these, of course, are all going to be 90 right here. Okay, moving on. So 135, my favorite number, STV. So this is 135. 35. This will be 135 over here. And what I'm doing, I'm just filling out the rhombus. I don't even know what they're asking for yet. This is going to be 45. This is going to be 45. These angles are going to be half of 135. These are going to be half of 45. And these are all 90. So what are they asking? They're looking for SVT. SVT. That's half of 45. That's 22.5 degrees. That's it. Don't overcomplicate. Moving on. Okay, another rhombus. DM is 24. So we know from a parallelogram these bisect, so that's 12, and that's 12. All right. LDO is 43. If that's 43, this is 43, and the whole thing is 86. If that's 86, this is 86. Okay. If this is 86, this is going to be 94 because they add up to 180. Alrighty, DL is 13. So if that's 13, all the sides are 13. These are all 13 in length. What are they asking? OM. OM, 12. DOL. DOL, that's going to be 90 degrees because it's a kite. Kites diagonals bisect at 90 degrees. DLO, that's going to be half of 94. Help me out. 45 plus 2, 47. All right. Okay, 47 degrees. DML, half of 86. That's 43 degrees, right? Oh, that's kind of given. All right, I think it was given. Yeah, 43. There we go. DP. DP is 13. Now, curiously, if they ask for like PO or OP, that's a squared plus b squared equals c squared. That would turn out to be a 5 because that's a 5, 12, 13 triple. Moving on. Squares, our last one. So squares have all the properties of a rhombus and all the properties of a rectangle. So it has all the properties of everything. So it has all the properties of a kite, trapezoid, isosceles, parallelogram, and the quadrilateral. It's like the ultimate baby of quadrilaterals. So it has opposite sides are congruent, opposite sides are parallel, diagonals intersect at 90 degrees, diagonals bisect, they're congruent, all these angles are 90 degrees. So squares are actually the easiest of the bunch. Since these are bisected, these are all 45, and you have your 45, 45 special rights. These are 90 degrees right here, so on. Kite squares are cool. So all I have to do is just give you one thing, typically a side, and you can find everything else using special right properties or whatever. So if this is 8, again, this is a rhombus, so all sides are equal. So these are all 8. And I can find everything even if I want to use my special right properties. So AT is also 8. Angle at HST, say that fast, is 90 degrees because this is 90. Okay, the corners are 90. MAT, M-A-T is 90. And it's either going to be, the angles are either 90 or 45. MHS is going to be 45. And this is a independent problem because we can't have HS being 2 and MH being 8. So if HS is 2, this would also be 2, this would also be 2, and this would also be 2. So HA is also going to be, HA is going to be 4, and MT is going to be 4. Okay? So that's pretty much it. Squares are pretty basic, nothing too exciting. Just keep in mind your properties. I'm going to go ahead and get this uploaded and run through this again with y'all tomorrow. Alrighty, see ya.